Hello students, welcome back to another video. Today we're starting our final unit on atomic, nuclear, and quantum physics. We're going to start off today with just studying the atom. So I'm going to jump right into the structure of an atom. Okay, here I'm using the helium atom as an example. This is a rough sketch of the structure of the atom. The nucleus of the atom is the center, which contains the protons and the neutrons. The protons are positively charged and the neutrons have no charge. Outside of the nucleus, there's a cloud of electrons. Of course, electrons are negatively charged. In order for that atom to have a neutral charge, it should have the same amount of protons as electrons. It's also typical that there's the same amount of protons as neutrons within the nucleus. Atoms that don't have the same amount of protons as neutrons are called isotopes. So here I've written that out here. An isotope is an atom where the number of protons does not equal the number of neutrons. And these are typically more radioactive. They break down more easily than a regular atom. We'll talk more about isotopes and radioactivity tomorrow when we talk about nuclear energy. An atom that doesn't have the same amount of protons as electrons will have some sort of charge, and we call these atoms ions. Okay, I'm not going to go into too much more detail about the atomic structure right now, but I want to take a moment to talk about the notation that we use on the periodic table to represent atoms. So we identify what kind of element an atom is by counting the number of protons. In this case, helium has 2 protons, so that is going to be our atomic number. The symbol for the element is usually a single letter or 2 letters that represent the name of the element. In this case, He represents helium. The last number here is the atomic mass, and because the electrons have such a light mass, the atomic mass pretty much mostly comes from the neutrons and the protons. So the number of the atomic mass will roughly just be the number of protons plus neutrons, in this case 4, but there's a little bit more mass added from the electrons. Okay, so here I've written out that the atomic number is just the protons, and the atomic mass is the protons plus neutrons. Since every element has a different composition of these subparticles, the protons, electrons, and neutrons, every element will react differently to light. So next I want to talk about the photoelectric effect and what that means. Okay, the photoelectric effect is the emission of electrons when light hits a material. So here I've drawn some material with electrons on it, and I have incoming light, and as a result of this light exciting those electrons, adding energy to the material, some of these electrons are going to come off of the material. These electrons that come off of the material are called photoelectrons. The last thing I want to talk about is the emission spectrum of an atom and how we can use spectroscopy to measure the emission spectrum. Okay, so what the emission spectrum is a spectra of light emitted when electrons move from a high energy state to a low energy state. To compare that to the photoelectric effect, the light was coming in and it excited these electrons, so it increased the energy. In this case of the emission spectra, these electrons are going from a high energy to a low energy state. If you observe this through a spectroscope is simply just a tool to observe the emission spectrum. If you use a spectroscope to observe an emission spectrum, you'll find that every single element has a different emission spectra due to its different structure. So every single element has a unique spectrum that's almost like a fingerprint for that element. So this is how scientists can figure out the chemical composition of different things. They can use spectroscopes to see what kind of elements are contained in that thing. This is also how they can figure out what kind of elements are in different planets and see if those planets might be habitable. We can detect if these planets have water, etc. It's pretty amazing how knowing about the tiny building blocks of all matter can help us understand huge things like that. That's going to be all for today's video. We're going to continue to talk about nuclear physics in the next lesson. Thank you guys. See you next time.